Hey, it's Joel, we're at Formnext 2025. I'm at the EOS booth with a part that was not possible at this speed or cost before this machine.
That is correct.
Hey, Fabian, how you doing, man?
Good to see you, man.
Good to see you. It's always cool coming to this booth because you guys, you have good coffee, but you also have really cool tech. And this machine behind us, brand new, makes this possible at a speed and a cost that wasn't otherwise available. Is that right?
That is correct, yeah.
So I'm holding something that was made in titanium, correct?
Correct.
Okay, Ti-64, I believe, is what you call it, right?
Yeah.
And what does this machine do that is able to make this go so fast and cost not as much?
Yeah, so this is the new M4 Onyx, which is the system we just launched yesterday, world premiere. It is a successor to our M400-4 system, which is the most widely adopted industrial metal 3D printer in the world. 500 of these machines are out there today printing end-use parts from gas turbine components all the way into different types of defense applications.
Okay.
And therefore what we've done is we've taken that super successful platform and improved all minor details that customers still had some thoughts about that we could improve.
Okay.
And we added some innovation on top.
Oh, so you took something good, the feedback, you improved it, and then you're like taking some thinky bits and you added in two and you came up with this.
Correct.
Well, take me through the parts of it real quick because it's a very large machine.
Correct.
And it's got material storage, it's got material printing, and then there's something at the end. Is that a post-processing station?
Yeah, we'll talk about that. So
okay.
It is a big machine,
yeah.
But it's actually not bigger than the previous version. In fact, it actually has a smaller footprint from an operational perspective, so you can actually get more machine of the same type into a facility. But the key innovation is 90% less hazardous waste. So we really reduced the waste of the system.
Okay, well, before we go on, so 90% less hazardous waste. For those that may not know, what waste is produced by a machine like this?
Correct, so in laser powder bed fusion, you use powder as a base material. And this powder, during the process, parts of it get taken into a filter system. And in the past, this filter system produced a condensate that was not oxidized. And due to the non-oxidation, you had a risk of a flammable material, right? And you had to go through separate steps in order to then make that waste non-reactive. And therefore you had a higher cost in disposal, and you also lost some powder.
Yeah, of course.
Now what we've done is we've reduced the amount of material that even gets taken away from the powder beds. We've added a cyclone that takes out that material and makes it reusable or recyclable. And whatever material gets left in the actual filtration units now goes through a controlled oxidation. So the final material is now non-hazardous. You can open it up to atmosphere, it would not ignite, and it can therefore also be disposed
that's great.
Safer and cheaper.
That's huge.
Game changer. It is a big step in laser powder bed fusion. In addition to that, we have added new scanners that make the whole processing faster. So we have a overall 30% faster process in especially titanium.
Take me through the process. Where would the scanning come into play?
Correct. So if you print in metal, you run really short and small vectors, right?
Yes, in the powder bed fusion, right?
In the powder bed fusion, correct. And we've added, and we can't talk too much about it, but we've added new innovative scanners that can do that more efficiently, and we optimize the tool pathing of the process, which also makes the process more efficient.
When you're printing with metals and you've got your laser path within the powder bed, if you go too quick, there can be problems with the metal powder as it's fusing it together. So you have to optimize your path in order to not have the laser introduce errata within the part.
Correct. There's two objectives that you have for process optimization. By process, I mean the process parameters.
Okay.
One are material properties, the other one is speeds. We were able to address both with this machine and with these parameters. So therefore we have a faster process, so our laser is more efficient in exposing our parts, and we have optimized material properties due to other process optimizations there as well.
In printing, let's say the part that I'm holding here, this is a suppressor.
Correct.
So this is possible in the previous machines you have.
Correct.
But with this one, what sort of improvements in time did you see printing it on this machine?
Sure, so now you actually print this part roughly 30 to 50% faster. And we've also added additional post-processing, material handling and part handling automation that overall leads to a 50% higher productivity and 30% reduced cost per part. One additional innovation that we added to this machine is what's called a dual job exchanger. And now we're really talking about lights out production. So if a print finishes, say at 3 a.m., the machine automatically moves the whole frame out of the machine, moves it up, a new frame moves into the machine gets flooded with gas, and then restarts the print all within 30 minutes.
Wait.
So at 3:30 a.m., the machine starts producing again.
I've been at your facility. I've seen metal printing happening. I've seen the laser hit the powder bed, and like there's a human process that is needed in order to prepare it. And you're saying you've automated that.
We've automated that process, correct. And therefore, even with the previous system in an industrial setting, we were able to hit 97% availability of these machines. Now we can match and exceed that. And therefore, you're really, really now talking mature industrial 3D printing for serial manufacturing.
Right, like lights out.
Like lights out.
Like lights out. That's amazing. And having a 30 to 50% increase in the speed that you're able to make this, customers can get their parts delivered sooner.
Correct.
This is huge.
It's huge. And now think about the implications of cost reduction, right? Today in metal additive, the application that are printed today were unlocked by previous technologies, right? Now with a lower cost, less waste, lower footprint of a machine and footprint requirements, you're opening up a whole new set of applications.
You start to unlock those legacy processes that are now like, oh, now we can use metal additive for this process where we couldn't before.
Correct.
You're starting to match legacy manufacturing process times with additive manufacturing times. And that's crazy to think about.
Yeah, it really feels like the whole industry is at turning points. I think you can feel it yourself at this trade show. The hardware, especially this machine, is at a point of true industrialization. Software is at a point of true industrialization. I think there is a very big growth curve ahead.
I want to throw it to you, Fabian. Like, what do you envision the next 12 to 24 months looks like at EOS with this machine?
I mean, what's interesting about this machine is that at launch, we already have orders in.
Shut up and take my money.
That is rare for a high capex equipment.
Yeah.
And therefore, we really see that we're hitting the market at the right time. I think we're going to see, like I mentioned, a lot of new applications being unlocked, and we'll see a faster growth curve and adoption curve in applications like this, right?
Well, and this isn't the only thing that you're showing off here either, too. For serialized production, I see watch faces right in front of us, and what are these? Particle separators. So you're starting to insert metal additive into more industries.
Correct, yeah. I mean, if you think about consumer goods, right? Consumer goods historically have not adopted, especially metal additive manufacturing, just due to the cost. As you can see here now, we can print many of these watch housings within 20 hours, right? Like this is now a 20-hour, probably less than 20-hour.
And it's serialized.
And it's serialized. Machine, like we talked, moves the frame out, moves a new frame in, starts to build again. We're really going to see also consumer good companies start to innovate with this, right? You'll see companies being able to enter the market at lower volumes because I don't need to stand up a casting or a whole machining facility, right?
Yeah.
So I think there's going to be interesting dynamics.
Formnext next year in 12 months, we're going to see some really cool customer testimonials, parts made with this machine. We're going to see some really cool demos. We're going to hop on camera again and talk about it and be like, can't believe in 12 months what we've done. This is amazing, right?
Yeah, and I hope I was too conservative.
Yeah, that's right. That's always the thing.
That's what I'm talking about.
Fabian, this has been an amazing chat about a really cool machine and incredible parts that it can make really fast and at a lower cost. I want you to tell everybody where they can go to find out more about this machine and EOS in general.
Yeah, go to eos.info, go to our metal solutions, you'll find our M4 Onyx page with all the specs, all the details that this machine comes with.
Thanks for watching. If you made it this far, you're awesome. Don't forget to hug each other more, fight for a cause you believe in, metal print all the things, and as always, high five. You want one?
Ooh, that was a good one.
Crisp.